Okay, we're starting with number 11 here in the notes, and this one's not incredibly hard, but to be able to have a chance of graphing it right, you got to know some of these things, like what the heck is an amplitude, and in our problem, what is the amplitude? Now, there's not too many choices for this. I mean, it's got a number in front. Is it just the number in front?
Not necessarily.
You're correct. It's not just the number in front. So, what do you think the answer is for this problem? Okay, hint, it can't have a negative amplitude. Now, what's the amplitude? Yes. The amplitude is just the number in the front, but you can't have negatives. So technically, it's the absolute value of the number in the front. You pass, sir, or was this, what were you up to? What were you up to?
I go to the health office.
Oh, okay, that's right. Somebody did mention that you had taken off to the health office. Don't they normally send you with a pass? And maybe not nowadays.
Did not go to the pass.
Okay, all right. Moving on, the B term. The B term is 2. What does it mean? Well, basically, you're going to be using this B term to change your graph. And normal cosine looks like this. If you haven't already, everybody please graph normal cosine. I am not an artist, so mine aren't perfect, but mine starts high and ends high, and that's the main thing it needs to do. It's like a valley. And so this is 1 and -1, but it's going to change. You always graph the parent one first, even including the 1 and the -1. And then you go to 2 pi. Pi. Now I'm cutting them in half. Half of 2 pi is 1 pi. Half a pi is pi over 2. And that right there tells me this one. Pi over 2. That tells me what I'm counting by. 1 pi over 2. This is so much easier. 1 pi over 2. 2 pi over 2. 3 pi over 2 goes right there. And 4 pi over 2 is the same as 2 pi. But what does it do? What does the B term do? You divide everything by 2. Or, I like to think of it as multiply by 1/2. Because you know multiply by 1/2 and divide by 2 are the same thing. But when you have fractions a lot, it's easier to multiply by a fraction. How many of you right now had 2 pi over 2 or pi right there? How many of you had a pi right there already? You knew that. No, not many people. It was 2 pi at the end. You should know that. If you haven't got that memorized, you got to memorize that. All right, then, why did we do that? Because there was a 2 right here. Because there was a 2 in the middle, we had to multiply everything by 1/2. And 2 pi over 2 became, 2 pi at the end there became 2 pi over 2, which simplifies down to just pi. And then you can go all the way back to the beginning and say the pi over 2 would get times by 1/2, and that becomes pi over 4. And that tells me what to count by. I'm going to highlight it. I'm counting by pi over 4s now. 1 pi over 4, 2 pi over 4. That's the same as what? Yep. And 3 pi over 4 and 4 pi over 4, which is of course the same as pi. It's so much easier to count this way. And the first number, that tells you what to count by. Okay. Now we got to figure out the phase shift. The phase shift. If you can factor this, you should. 2 comes out to the front. Once the 2 comes out, I have x plus pi over 3. No. Think about this. If I put a pi over 3 right here, and you multiply the 2 back in, it doesn't give you pi over 3. What you're really doing when you factor something is dividing by that number. So let me try to teach you in a good way how to do that. So imagine for a second our problem had been this. 2x plus 16. 2 can factor out. And so you get x plus what? Well, you're dividing both of them by 2. Or you could say multiplying both of them by a half. Do you get what I'm trying to say? What I'm trying to say is you divide both of them by 2 at the same time as you multiply by 2 in the front. And that's what kind of undoes it. When you're factoring, that's what's happening. You're pulling something out and dividing both of the others. So, if you really got that, 16x plus 8. Factor out the 16. I know normally you wouldn't. Normally you'd factor out the 8. But factor out the 16. If you get this, then you're going to start to get what we're doing in the trig problems. I always like to try to bring it back to simpler numbers, simpler days, back in the good old days. You are correct, sir. Why don't you say it out loud?
16 times x plus 1 half.
Yep. Because really we were dividing both of these by 16, see? And 8 divided by 16 gives us our 1/2. Okay, so when I factored the 2 out, I was really dividing both things by 2. See what I mean? So then this is 8 divided by 2. All right. Now, when I took a 2 out here, I was dividing both of these by 2, which is the same as multiply by a half. Pi over 6. How many of you beat me to that and you had a pi over 6 there? Good. Okay. That is one of the hardest things. It's factoring in that weird way. That gives us the b term and the phase shift. But I bet a lot of you just wrote pi over 6. That is wrong. Can you be more specific? Yes? You are correct. Left pi over 6. Phase shifts are directional. You know how there's a plus in there? Things that are plus seem like they should go to the right, but they actually go to the left because they're on the inside and you don't trust them. So this shifted left pi over 6. And last but not least is the vertical shift. That's this. Negative 1/2 is the vertical shift. All right. Again, the next one that we have in the notes is just too brutal. We were not going to have any of that part. So I'm going to give you a different one. That's an alternative. Negative 4 cosine of 6x minus pi. I want you to try graphing that one. You should know that it's got a phase shift. You should know the b term. So let's start by just making cosine's graph. Here's cosine. I like to think of it as a valley. Here's 2 pi. Here's pi. Here's pi over 2. Here's 1. Here's negative 1. That's supposed to be coming really easy now. If you haven't got cosine memorized, you've got to get that memorized. All right, so then the negative 4 in the front is actually not too bad. Do you know what to do? Not the negative, but just with the 4.
That's the amplitude?
Yes. So how do I change my graph? Hint, 2 of my numbers need to change to 4s.
The 1 and the negative 1?
Yeah, this changes to a 4 and a negative 4.
It's a vertical structure.
And now, yep, it is a vertical thing. And now with a negative. The fact that says a negative in front means I got to do something. Hannah, what do you think?
You flip the graph.
All right, so I'm going to change it to this blue graph now. Not perfect, but it's close. I would have given you credit on a test. There, now I've handled the 4 and I've handled the negative. Now we got to do the 6. It's really pretty simple. I'm gonna change all of these numbers. I'm gonna circle them right now. All these numbers need to change. Oh, and I missed one. The forgotten child. I even said it before like that. 3 pi over 2 is often neglected. There. Now it's there. That's my starting numbers though. Lila, that 6 has something to say. What do we do with it? So, factor the 6 out. What do you got left?
X minus pi over 6.
You got it. And that 6 now has to change all the numbers I circled in red. This and this, all of those have to have a 6 in them somehow. What do I do?
Multiply all of them by 1/6.
Multiply them all by 1/6. I like it. Could have said divide by 6, but actually multiply by 1/6 is more versatile because it handles fractions too. So pi over 12. And this is 2 pi over 12. You might want to say pi over 6, but I want to say 2 pi over 12 so that I can just count. 3 pi over 12. It's going to end up being the same thing. And 4 pi over 12. And I get to count like a little kid. 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12. Instead of doing complicated math. I know little kids don't talk about pi over 12s, but it's 1, 2, 3, and 4. I'm okay with you leaving them in this case because by doing that, you're showing me that you're being smart. It's rare that by not reducing something, you're being smart, but trying to memorize a sequence like pi over 12, pi over 6, 3 pi over 12, and pi over 3 is not a memorizable, like logical sequence. And 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12 is so clean and nice. Okay, last but not least, I have to shift it. This part's not super fun, but you guys, because you use Notability, I'm using a recording device called Explain Everything, and it doesn't have this feature. You guys have the ability to use your little lasso on your iPad, and you just lasso the blue, and you're going to drag it. Which way? Right or left? Right. Because of this, the phase shift is what we're doing right now. You would drag this blue graph to the right. How far? 1 pi over 6, which would be the same as 2 pi over 12, which is this far. Look what I'm doing here. This is how far you need to drag everything. That far over. So this tip right here, the bottom, that tip right there, will be moved over 2 notches. The peak will be moved over 2 notches. And the ending will be moved over 2 notches. So this is ugly, but it's basically in the right spot now. The green one would be your final answer. It got flipped, it got moved, and it got stretched in both directions. That was as bad as we could ever do on a test. Like that, you'll never have one harder on the test. Yes?
Do you always do it in the order A, B, C, and then D?
Yes. Because, I don't know if you noticed this, but I renumbered it first before I actually moved it. And that was important, because do you get if you would have moved it earlier, you would have moved it a different place, which would have been wrong. So yes, you should do them in order A, B, C, and D, because that'll make you renumber it first, because you do that on the B term part before you phase shift it.
Yeah, thank you.
It's a good question. Okay, now I feel like you got it. I'm gonna give you one. It's kind of like medium level, not as hard as that one even. One medium level one. Let's see if you can do it. Question first.
Should you continue the graph
That is a good question. You do not have to continue the graph for more than one period. It starts, my green graph starts at the bottom, ends at the bottom. That is one complete cycle, and you don't have to do more. Now, if the test said do 2 periods of pi, or sorry, 2 periods of cosine, then you'd have to do that. But I'm fine with leaving it the way it is. One thing you should do if it's actually test, you'd have to erase these. You would not leave the old, images of what it used to be. Those need to be gone. That's where the graph used to be. There. Okay, so here's one that you can try to see if you're really on track now. At the beginning of the hour, I would have expected you to know how to graph like 4 cosine. Now, I'm wondering if you can do this. 3/4 sine of 2x minus pi. Can you graph that? Now this is in parentheses, so you can tell that that's going to give you a phase shift and all that. Give it a shot. Give me a final graph. Act like it's a test. So Ben, what's the parent function here? Like the most simplest. Very nice. Sine starts at the origin, and that's a wave. I don't think I could have answered that any better myself. There. Where does it end, Ben? Takaratornga. Take it over from there. One pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2 is 2 pi. We can leave it as 2 pi. All right, Aaron D. Tell me something to do with 3/4. You are correct, sir. One becomes 3/4, and the other one becomes negative 3/4. Emma Nebula, can you tell me what to do with the factoring here? Can you factor that for me? X minus pi over 2. All right, and let's go to William Zong. Tell me, should I renumber it first based on the 2, or should I phase shift it to the right pi over 2? You change out the numbers first. So I'm going to multiply everything by 2. What should I do? Yes. That's the same as dividing by 2, but I like to write 1/2, 1/2, 1/2. Did you have pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4? Or you could have reduced them, of course. Okay. I'm done. No, I'm not. One more thing. Yang Hai, what haven't I moved yet?
You haven't phase shifted it.
Yes. How far am I supposed to phase shift it?
One phase shift by. Oh, you already found it. It's negative, so you move it right.
Right how far?
Pi over 2.
How far is pi over 2? 1 mark? 2 marks?
2 pi over 4, which is
2 marks over. So everything gets moved over 2 marks. So I'm going to take this point here and move it here. And then I'm going to start my sine wave there. Now I'm going to have to extend my page out to be able to do this. There. There. I moved it over 2 marks. Now, one thing that's also handy about this numbering system, 1 pi over 2, 2 pi over 3, 3 pi over 2, 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and that spot right there is 5 pi over 4. And it's so easy because I got that numbering system, you know? I'm telling you, copy me on that because we want to number out all the way to the end of the graph. Did I move it over? No, I didn't move it over 2 marks today. Dang it. Just realizing I did not move it over 2 marks. Yep, my red graph. I goofed my red graph up. Hold on. I'm going to erase it. I apologize. It was going through slightly wrong spot. It starts here. That was good. Part of what messed me up was there's a mark right there that I didn't show. All right, now everything's over 2 marks. 1, 2. If everything goes over 2 marks, I got to make an extra 2 marks. You know, this guy and this guy, those are the extra ones. Now, I could start here. I'm going to make it green this time. There we go. Okay. So everything got shifted to the right. That was the hardest thing, for sure, the phase shift. Any questions? That is it. Now, what do we do next? Tomorrow's kind of weird because we have some juniors who are going to be taking the real ACT again. Or sorry. Yeah, the ACT, the actual ACT. And it's not really again because we didn't take it last Tuesday when we were going to take it, but then the ACT made us move it. So anyway, how many of you in here are real juniors? Like, actually, this year you are a junior. Okay, 1, 2, just 2. Okay, in the classroom. Oh, 3. At home, the online kids, put your virtual hand up if you're a junior. All right, I got 2 at home. All right, so those of you that are at home, I hope you know that if you're taking the Minnetonka, which you didn't have to, but the Minnetonka ACT, which most juniors take, it happens tomorrow here at school. In respect of that, whatever I assign tomorrow, the juniors are not going to have to do that assignment. But you do have to know the stuff for the test. So watch the video for tomorrow to see exactly what I decide to cover. I don't have many juniors, which means I don't want to just take an entire day off for the rest of you because then we'll end up running out of time at the end of the year. So bottom line, I think we're going to forge ahead, but not too far. And juniors will not have to do that homework. Just have to know how to do that stuff on the test. So watch the video. Okay, so what's the homework right now, Mr. Server? The homework right now is a quiz that we're going to take in class and finish by Thursday. Why Thursday? It's only Tuesday. Because tomorrow, it's not even Tuesday. Because tomorrow the juniors are gone. And Wednesday we are at home. So Thursday is the next day I'll see some of you. Okay, so I'm signing it right now. Everybody open up the homework called, it's not even called a homework assignment. It is called Starter Quiz, due Thursday. HPC Starter Quiz, due Thursday. I'm putting it up on the board so everybody can see it. It starts right there. the first and the second one are super easy. You might be like, well, how far over is like pi over 2? You get to decide what feels right to you. If you want to make 2 marks be pi over 2, you can do that. If you want to make every mark be pi over 2, you can do that. Okay, so this, you just have to label your little marks. So if you decide that feels right to me that if we go up 4 marks, that should be where 1 is on the y-axis. 4 marks up is where 1 is. That would be good. Maybe you only want to make it 2 marks up. That would make it an even number because most of our numbers are like, it would work nicer if you make it an even number of blocks. All right, so act like this is a test. If I were you, I'd try to finish it in class. And if you do, you don't have any homework between now and Thursday, other than taking a look at the problems that would normally be assigned at the end of the unit, or at the end of the lesson. But this quiz will be graded in class on Thursday, first thing. So get it done. You got 2 days. Should be doable in a half hour, much less 2 days. Okay? All right, that's all I got for you for the video for today.